Welcome to the Analysys Mason podcast, Wireless Networks on Digital Sustainability, What is Arcep Approach? My name is Gilles Monniaux, and I'm a principal at Analysys Mason. My guest today is Ahmed Haddad from Arcep. Ahmed and I have known each other for nearly 10 years and worked together on multiple techno-economic modeling projects over that period. Ahmed, can you tell us a bit about yourself?
Good morning and good afternoon, Gilles. So I'm technical advisor at French Telecom Regulation Authority, Arcep, working within the mobile telecommunication and technology innovation department. My role is to support my colleagues through technical expertise on telecommunication networks, ICT, and on environmental sustainability considerations. Before joining Arcep, I've been working on technology, telecom and media consultancy, and R&D management. Pleased to be with you, Gilles, in this podcast.
Thank you, Ahmed. The context of this podcast is the recent study that Analysys Mason did for Arcep to assess how the use case on the network infrastructure of wireless networks would evolve or may evolve. The main conclusion of this study have been published recently on the Arcep website in both French and English. The study aimed to identify some key potential use cases on network development that could have an impact on the demand and supply of wireless networks and assess potential scenarios to understand the risk of networks running out of capacity. The study also included an assessment of the carbon footprint of the various scenarios, which is an example of the importance that Arcep gives to digital sustainability. From a methodological point of view, the study was rigorous and included both a thorough specification phase, backed up by literature review, and a consultative committee of 4 academic experts who reviewed all the deliverables. Moving on to the first topic of today's podcast regarding the evolution of wireless networks, does Arcep consider specific use cases to be particularly important for the evolution of wireless networks?
Well, as nobody has a crystal ball to look into the future, it's challenging for us to pick some specific use cases as the main driver of the evolution of wireless networks. The approach we have followed in the study conducted by your team and that we published last September was to categorize wireless demand use cases according to their location, either indoor or outdoor, and according to their requirements in terms of network service performance, such as bandwidth, latency, and communication reliability. Then the study focuses on mobile internet services, which are those that generate the most traffic and create the highest demand in terms of network capacity. Or say it differently, the model was designed to reflect throughput as the main metric of interest. So legacy services, let's say voice, SMS, and simple low-power narrowband IoT communication are excluded from the modeling as they do not influence network dimensioning in the same way as the most demanding use cases. So with this approach, we are not reinventing the wheel, as it's quite aligned with how telecommunication networks have been dimensioned so far in order to fulfill the objective of this study, which is identifying through macroscopic view the risk of network capacity breakup because of radio spectrum shortage or even spectrum inefficient use. The uncertainty lies on whether there would be specific use cases that, if they would go viral, may shift the distribution of traffic between indoor and outdoor or boost uplink communication, whereas we have been used to dimension the network on the basis of the downlink traffic. These two spots of uncertainty might have non-negligible implications on the way network is designed and on the supporting key assets like radio sites and also spectrum.
Thank you, Ahmed. Very interesting. Can you give us an example of one use case with uncertainty?
So let's take the example of AI, for instance, where we notice a growing trend to streamline its adoption and seamless integration both on user equipment and user applications. How AI would impact wireless networks. This was an area of investigation at Arcep, where we published a first forward-looking note on this matter, 20, and a second one as a follow-up 4 years later. In a nutshell, regarding AI, there are 2 main areas of uncertainty. What is the take-up of AI? And second question, how AI would develop. For example, in the study we carried out with Analysys Mason, AI was considered as a catalyst to existing use cases rather than casting new ones. In other words, the impact of AI is taken into consideration in each of the modeled use cases without being considered a use case in itself. Generative AI, for instance, may amplify content-based use cases such as video traffic or streaming, while agentic AI, for instance, may be key lever in revamping IoT communication. But as I mentioned in the beginning of the talk, let's be humble on how the future may look like. After all, we have been already told last decade about the blow-up of massive IoT communications, which were expected to rethink how networks would be planned and operated. This is said, the study acknowledges some uncertainties on the incremental impact of AI. One may advocate that the uplink traffic would be boosted in the first years of adoption of AI services, which may challenge the network. This is because AI models would need to be trained and also fine-tuned to make them ready for effective usage. This may require probably the retrieval of massive amount of data from the user side and to be transmitted to the cloud. Others, on the other side, may envision this change happening, but at a softer pace, as AI-capable end-user devices would be powerful enough to proceed and to handle local processing, together with distributed and federated machine learning, may make the first scenario not so likely and will still dimension the network roughly as we have used it to do.
Thank you. So given this uncertainty across use cases, how can a regulator like Arcep make decision? After all, as you said, you don't have a crystal ball.
Yeah, if you go back to AI, so if would AI be the game changer? It's difficult to get a confident feedback at this stage, which is, needless to say, as you mentioned, quite not comfortable position, not only for a telecom who operates a network, but also for spectrum manager. Those to handle this uncertainty, scenarios were envisioned according to the usually called what-if thinking approach. More specifically, 4 scenarios were considered in the study. We have basically the restrained consumption scenario where digital sufficiency is promoted, median scenario, a kind of business as usual development scenario, and 2 additional scenarios, namely increased digitalization and disruptive uses, reflecting an increase in the adoption of advanced use cases beyond the historic levels. But it's important to mention that it is left up to the reader to assess the likelihood of each scenario. So our aim with this study was to unfold the possible range of future scenarios from the most conservative development to the most disruptive scenario without being prescriptive on the specific scenario.
Okay, thank you. To summarize, multiple use cases mapped to 4 scenarios with demand forecasts and this important precision that neither Analysys Mason nor Arcep have assigned a specific probability to the individual scenarios because the study is more to answer the what-if questions rather than forecasting the future. Moving on to my second question, does Arcep consider certain developments in wireless networks particularly important for the network capacity to absorb usage?
Well, we may be tempted to think that exploring how future developments in wireless networks would unfold might be easier than figuring out how the demand would evolve in the future. This might be true in general. Meanwhile, we should not forget that standards and white papers are plenty of new network functionalities that at the end, their expected benefits didn't materialize in some way or another. Here again, I would share some insights from the study, where in our exploration of the full spectrum of possibilities, we adopted a pragmatic approach. As we aim at identifying the tipping point where congestion may occur, mobile network evolution scenarios considered in the study follows a stepwise approach. These scenarios represent a progressive increase in network capacity through additional spectrum allocations and technological development. Therefore, any gap in network capacity to serve the demand would be fulfilled through deployment of additional radio sites. In total, we can say we have 5 scenarios that have been considered. Scenario A, where operators keep their current spectrum holdings. This is meant to investigate the limit of the current snapshot. The second scenario, scenario B, under which operators optimize their current spectrum holdings by refarming and reshuffling existing bands. This is meant to explore the limits of maximizing the reuse of existing spectrum assets and avoid deploying additional new radio sites. The third scenario, which is scenario C, in which we assume that operators increase their capacity through increased network sharing, with the greater sharing of existing sites, and also the activation of existing spectrum bands on radio sites where they have not yet been deployed by any operator. At last, we have also investigated the case where operators use and deploy additional spectrum bands. In addition to the timeline of radio band refarming, the study also makes assumptions on existing wireless networks engineering rules, and notably the timeline of massive MIMO evolutions for each cellular technology and each type of spectrum, either low band, mid band, or even millimeter wave.
Thank you. Very interesting. So what were the main findings of the study and what are the potential implications?
So actually, the study was able to unveil the incremental added value in terms of additional capacity of each network development scenario. From a spectrum policy manager like Arcep, this is of paramount importance, as we usually have this recurring debate between maximizing the efficiency of the existing spectrum portfolio through refarming and the new capacity brought by additional spectrum. While each scenario fuels the network with an additional capacity, the study shows especially that deploying additional bands enables the highest incremental increase of network capacity, thus avoiding deployment of new radio sites. Interestingly, the third scenario, which is scenario C, which assumes increased network sharing in addition to deployment of existing bands where they are not yet where they are not yet deployed, this scenario is foreseen to provide a substantial additional capacity, but this comes at the cost of significant number of radio sites related to the implementation of network sharing itself. To support the reflection of and figuring out the range of possible venues that were taking a deep dive, these findings are certainly helpful for us. But as any modeling, they are subject to uncertainty, especially when we talk about the performance of new bands for which trials are still ongoing.
Thank you very much. So to summarize across the first two questions, 4 demand scenarios and 5 network development scenarios to explore all the possibilities of how the wireless networks may evolve. So moving on to the second part of the podcast around digital sustainability with the first questions. What are the environmental impact hotspots of the ICT sector?
Yeah, till now, several studies have assessed the impact of the ICT sector either from public entities or private stakeholders, including think tanks and ICT companies themselves. And roughly speaking, the identification of the hotspots is quite similar. According to the study of digital carbon footprint in France, jointly commissioned by Arcep and ADEME, which is the French environmental agency, we see that devices account for nearly 80% of digital carbon footprint, compared to around 15% for data centers and little 5% for networks. So clearly the main focus point here is on end-user devices. That was the outcome of an assessment reflecting the picture in 2020. Since then, the assessment has been updated, mainly to align with the most recent data set on the inventory of assets, but also to introduce some methodological adjustments. I'm not going into details. Put it simply, we have to consider the impact of ICT attributable to French usage, even though being located abroad. So the updated assessment shows that we have an increase in the share of the impact of the ICT sector and the national carbon footprint, but also we note a change in the distribution of this impact between ICT subsectors. We end up with 50% for end-user devices, 46% for data centers, and the remaining is left for networks. The hotspots are those clearly identified between terminals, end-user devices, and data centers. The high volume of equipment and their frequent renewal cycle are basically the main reasons, in my opinion, terminals are identified as the first hotspots. Specifically, most of the carbon footprint has been already emitted on the production stage. Obviously, these figures reflect a high-level panoramic view. A closer look would suggest disparities between the type of devices. For instance, when we compare smartphones with laptop, with IoT, and so on, and the type of networks and the type of data centers, like hyperscalers, edge data centers, or also traditional low-performing data centers. This is said, just bear in mind that this task of screening the impact of the sector to identify hotspots is usually in the frame of an initial assessment lifecycle accounting. It's just to bring the attention of the practitioner and the policymaker onto the key area of intervention, or at least deep dive assessment. We should not miss the point that this approach for categorizing the ICT sector into subsectors, as I mentioned in the beginning, is kind of intellectual task. What I want to stress here is the fact that these assets, data centers, networks, and user devices, supporting devices like UPS and so on, are interconnected together, so they are not separated into silos as one may think. More devices or more sophisticated devices put on the market pull the network, At the same time, as enhanced capabilities of networks motivate further consumption and sometimes premature replacement of devices, we can unfold the same story when we speak about the relation between data centers and networks with the push of AI or other emerging digital services. Beyond the screening approach, we need to assess the interdependencies between these subcategories. And this quite robust approach that might be used, such consequential lifecycle assessment, reflecting the interdependencies through dynamic systems.
Okay, thank you. So a very large impact from devices and data centers, but the interdependency between the different sectors should not be ignored. Because after all, what would be the use of a device if you didn't have a network on a data center to provide services?
Exactly.
So given the environmental impact you just explained, which is quite important, how does Arcep integrate sustainability considerations in its regulatory policy?
Yeah, let's go back first to the beginning, since which Arcep has focused on sustainability considerations. So Arcep began to work on digital technology environment impact in 2019, and since then it has been steadily entrusted by lawmakers with new duties to collect data from ICT organizations on their environmental footprints. This data collection process, which began in 2020 with the country's four main telcos, Big Telecom, SFR, Orange, and Free Mobile, was later expanded through the REIN2 Act at the end of 2021 to include data center operators, operating system providers, public online communication service providers, device network equipment suppliers. So the integration was quite incremental. CEP makes this work public through its annual survey called Achieving Digital Sustainability, which provides with the ability to track the progress of greenhouse emissions, energy consumption, device recycling and refurbishment, water consumption, and so on. Thanks to this law, the survey is expanded every year to include new stakeholders or the collection of new types of data. In 2024, for instance, it was completed by the collection of environmental data on mobile network equipment, where we collect data on the main hotspots of the radio access networks, such as passive and active antenna systems, those used for 5G, radio unit devices, and equipment used for traffic processing at radio sites. In addition to this data survey on sustainability, Arcep integrates environmental sustainability into its regulatory policy through different forms, for instance, by encouraging passive network sharing all over the territory and even active sharing of mobile networks with respect to specific conditions and in non-dense area, by conducting also studies on reducing the reduction of the energy consumption of set-top boxes, which have been identified as one of the hotspots with the end-user device ICT category, by also leveraging on the expertise of its different technical expert committees to investigate the carbon impact of 2G, 3G network shutdown, to challenge through comparative analysis the energy consumption between 4G and 5G networks, and also by systematically requesting in Arcep's public inquiry the feedback and the view of the IST sector stakeholders on the impact of future radio spectrum assignments and allocations. But the most important thing is that because the integration of environmental sustainability into the regulatory work is also a proactive contributor to public debates and plays an active role on the national, European, and international stages, we are always eager to share our experience as Arcep and the findings of our work, this matter, and set up a collaborative framework with other organizations when it is requested.
Okay, thank you. So I understand that a lot of the material that you mentioned is present in the form of studies and reports on the Arcep website, so the listeners can go there to see those works. Building on your mention of working with organizations, what are some of the other organizations and stakeholders with which Arcep collaborates on environmental matters?
Yeah, at the national level, we collaborate with other regulation authorities and public entities, such as Arcom, which is the audiovisual communication regulator, and also ADEME, I mentioned before, the French Environmental Agency. I have already mentioned in your first question the collaboration with ADEME through the joint study on the environmental impact of the ICT sector in France. On October 2024, Arcom and Arcep, in tandem with ADEME, published a study on the environmental impact of the audiovisual media consumption in France in 2022 and up to 2030. So we are talking about the impact of video consumption, streaming platforms, and social media through different network access means, such as satellites, stereo broadcasts, IPTV networks, or radio cellular. This study can be seen as the equivalent of the Arcep Adam joint study on the impact of the ICT sector in France, but this one is focused on what we call the entertainment and media sector, or more precisely, a subset of that sector. The study that didn't include the physical part of it, such as printed media and physical cultural activities. So the study showed that the audiovisual media consumption represents the equivalent of around 1/3 of the ICT carbon footprint in France, as calculated by the Arcep Adam study. Looking forward, if no steps are taken to control the growing environmental impact of audiovisual media consumption, the study concludes that the carbon footprint could increase by 30% by 2030. We have been involved also as an advisory role in other different studies led and managed by Adam. We bring our proven expertise on ICT and especially on how digital technologies and networks are managed and planned and designed. In a nutshell, we have been involved in design of product category rules, which are kind of specific methodological guidance on how to assess the footprint of digital products. These product category rules were very common in other sectors like clothing, food, beverage, and they are required as a prerequisite for eco-labeling. This is when the policymaker wants to better shift consumer behavior toward more sustainable products. So we have been participating on design of product category rules related to several digital services like internet access service, data center, cloud computing service, local area enterprise networks, and to name a few. And supporting Adam also in other important studies, such as the impact of ICT on mineral and metal requirements, the potential of avoided emissions of ICT solution in other sectors through digitalization, which is a quite challenging topic about which the ICT industry was strongly vocal. I may be too long to go into the detail of each study, but I recommend the audience to check our website where our colleagues from the communication and the press office have done a great job in synthesizing our achievements and collaborations in a dedicated webpage. Since several years, sustainability considerations were natively as part of major studies, either realized in-house or externally. This was the case, for instance, when at the early stage of 5G deployment, we compared the energy consumption of 5G versus 4G radio networks, when also there was a debate on the environmental impact of 2G, 3G network shutdown. A specific study assesses both the environmental benefits and losses on that matter. And more recently, we published it with the support of fruitful collaboration with Analysys Mason. An original study investigates how can mobile radio access networks, which includes radio sites but also frequencies, be adapted to fulfill future mobile usage needs, take into account the associated carbon impact under different traffic scenarios. We also devote a specific attention to solve methodological difficulties when assessing the environmental impact of ICT. Jointly with Adam, we have set up since 2020 a specific experts committee focused on this specific subject. This committee was our proposal to tackle the lack of institutional exchange framework, gathering ICT environmental technical experts without immediate regulatory, competitive, or business considerations. This is why it is chaired by Nokia and gathers both actors from the ICT industry and from the sustainability ecosystem. The committee published 2 reports. The first one in 2022 aims at identifying and solving the methodological gaps when assessing the environmental impact of the ICT sector. And the second one, published 1 year later, investigated the boundaries of Internet of Things and connected products with respect to the ICT sector, through which we aimed at making the carbon accounting meaningful, considering that with the ever-increasing pace of digitalization of our society, the boundaries between ICT and non-ICT may be quite blurring. So now the committee is working on the connection between radio spectrum policies, impacts, and climate change, which is at the heart of our duties as a radio spectrum manager, which is quite challenging topic with obvious implication for us as radio spectrum regulator.
Thank you. So obviously you mentioned ADEME and Arcom, which are both French organizations, but what about collaboration at the international level?
Exactly. So all these efforts and numerous outcomes will not reach their full momentum if they are kept at the national scale. Our strategy to raising awareness on sustainability at the international level targets different channels. At the European level, Arcep co-chairs a dedicated sustainability group within the BEREC, the body of European regulators, to fuel the interest on sustainability between our European peers and coordinate the strategy with the European Commission. At the international level, we closely work with the International Telecommunication Union, especially the development sector, which we call also ITUD, to promote Arcep's proven track on environmental track data collection, and with the ITUT, the standardization sector, to leverage on our expertise in terms of assessment methodologies and environmental accounting. Our last achievement, for instance, on this specific matter was the recent consent by ITUT experts on the new version of L1450 of the ITU standard, specifying how to assess the environmental impact of the IC sector. The standard was updated based on the findings and recommendation of the two reports published by the Arcep ADEM Expert Joint Committee that I mentioned before. So we are looking forward this publication of this new standard expected at the end of the year.
Okay, thank you. So to summarize, Arcep is doing quite a lot in terms of looking at how the wireless networks, both in terms of demand on the networks themselves, might evolve in the future, and is also focusing quite a lot on digital sustainability and how a regulator can support those. Thank you, Ahmed, for joining us today, for your time and your contribution, and thank you.
Many thanks.